Hello, this is the answer key to practice question one. So here, let's read the question first. It's Monica consumes only good A and B. Suppose that her marginal utility from consuming good A is equal to 1 over QA. The marginal utility of A is 1 over QA. Marginal utility of B is 1 over QB. And the price of A is 0.5. The price of B is 4. And her income is 120. So the question is to ask her how much of A will she purchase? Okay, so basically you're asked about QA, and in the same time, we may be able to also calculate QB. Okay, so I'm gonna go over this for you. Right, so let me stop share and focus on the document camera in which we have translated the verbal illustration into math symbols. Okay, so this is a typical utility maximization problem. Okay, basically here we have the budget constraint of good A and good B, and we are to find the very point on the budget because we are to deplete the budget that gives us the highest utility, right? The highest indifference curve in this case. So what we first need to do is the tangent condition so that the slope of the budget constraint equal to the slope of the indifference curve. And as introduced in class, here a better version of that is the equal marginal principle. So it's the marginal utility over the price of one good equal to marginal utility over the price of the other, or here the consequence over the cost, or the return over the cost, right, for each product. So for each unit of product. So now let's plug them in, right? So here it is 1 over QA over the price of A, 0.5, equal to 1 over QB over the price of B, which is 4. Okay, so now you have many ways to solve this. What I like to do for this fraction over fraction is cross multiplication. So here what we have is 4 by 1 over QA equals to 0.5 by 1 over QB. Okay, and here what we can do is we can divide 0.5 to both sides of the equation so as to eliminate the decimal. We don't want a decimal and fraction to appear at the same time so as to mess up things. Okay, so what we do is we divide 0.5. So 4 over 0.5 is 8 by 1 over QA equals to just 1 over QB. Or we can rewrite that into 8 times 1 over QA, which is the same as 8 times the numerator, which is 1 over QA. That equals to 1 over QB. And then here we have this fraction equal to fraction. Again, we can do another time of cross multiplication. So 8 by QB equal to QA. And this is normally what we can get from this equal marginal principle. So we can work out the relationship between Q and QB. Okay, so this is one that we label here. That's step one. And step two, don't forget here this point is a tangent point so that the slope being equal to each other, but the tangent point in nature is also an intersection. So this point applies for the budget constraint, applies for the indifference curve. However, the indifference curve is something that we don't know because we are trying to find out the highest utility, right? Therefore, we are using the one that we know for sure, which is the budget constraint. So here it is PA by QA plus PB by QB equal to I. Okay. And then what we need to do is we need to plug in numbers, right? So PA is 0.5, but QA plus PB is 4 by QB equals to 120. So that is your equation 2. And we have two equations to solve for two unknowns. So here the easiest way is to replace QA with 8 QB. So it is 0.5 by 8 QA plus 4 times of QB equals to 120. Okay, 0.5 by 8, that's half of 8, which is 4. QA plus 4Q. I'm sorry, 4QB plus 4QB. So here we replace QA with QB already. 4QB plus 4QB equals to 120. So it is 8QB equals to 120 QB, and here I label this as star, telling you this is the optimal decision to purchase QB. That's 120 over 8, which is 15. And QA, which is what the question asked. Here we use this one, which is easier. I mean, you can also use this, plug this 15 back, QB, back here and to calculate QA, but here we have easier one, right? So QA equals to 8 times of QB, and 8 times of QB we know already, 120. So that will be the answer, okay?